Okay. Find the value of two numbers if their sum is 25 and their difference is 3. We're going to Melcon this. We're not going to write a paragraph. We're just using the elements of Melcon to help us organize our information. Melcon, main idea, evidence, link, conclusion. Okay? Looking at our problem, find the value of two numbers if their sum is 25 and their difference is 3. The two things we have to think about. Every system has two variables, and every system has two equations. And an equation has an equal sign, right? Every system has two variables and two equations. And an equation has an equal sign. So the main idea, it says, what do you know? From this problem, I can tell you some information. From this problem, I can tell you some information. It gives me information in that problem. What does it tell me in this problem? What does it tell me, Brenna?
That their sum is 25 and their difference is 3.
Perfect. So it tells me the sum. And what does the word sum mean? When I add them together, it equals 25. Is that true? It gives me an answer. Yes? My first answer it gives me is 25. In this problem, it also tells me what? The difference. And what does difference mean? Subtraction is 3. Good. What do I know? It tells me two answers. Because systems of equations have two equations, and equations have equal signs. Yes? And now it says, what are we being asked to find? What are we being asked to find? That means define the variables. How many variables do there have to be? Two, because that's the way an equation or a system works, right? Two variables. And we're going to assign values, information, names to those variables. What am I trying to figure out? Yeah, I want to know the value of number 1, of the first number. And I want to know the value of the second number they give me. So I'm going to assign those variables. I'm going to say x and y. That's what the problem tells me. That's my main idea. Evidence, E, set up the problem. I'm going to give mathematical evidence of this. Are you ready? I'm going to have some equation that equals 25, and I'm going to have another one that equals 3. How should I set those up? What equals 25? The sum, right? X plus y. Perfect. What equals 3? The difference, so x minus y. Excellent. That's all we do for evidence. We write the problem. Now we're going to link, which means we're going to use the problem that we did to get to the answer. Yes? How do you want to solve this problem? X plus y equals 25. This system, how should we solve this system? What would you like to do? Would you like to graph it? Could you graph it?
Yeah.
Yeah, but we don't want to, right? Do you want to substitute? No, not really. You want to eliminate? Why do you want to eliminate?
There's a positive y and a negative y.
Yeah, my y's are perfectly aligned to be eliminated. Boop, boop.
Bye-bye.
Now I'm going to combine like terms vertically. What do I get with x and x? 2x equals, what do I get with 25 and 3? divide by 2, divide by 2, x equals, am I done? I'm going to take this 14 and I'm going to resubstitute it into one of the equations. Sure. 14 plus something equals 25. Y equals 11. Now here's the difference. When we've been doing systems without word problems, meaning they give us the two equations and we start working, our answer has always been what? An ordered pair. If I asked you, hey, can you tell me two numbers that have a sum of 10? What would you say?
5.
You'd say blank and blank, correct? You would not draw me a graph and then plot an ordered pair on it, right? This is not an ordered pair. Because you could say that the answer is 14 and 11, but what else could you say? You could also say 11 and 14. It does not matter which one comes first. When we do a system, right? When we do a system like we've done before, did you have to put them in the right order? Yeah, you did. One of them was an X value and one of them was a Y value, correct? But here, it's not really an X value, right? And it's not really a Y value. It's the numbers 14 and 11. Because it's a word problem. It's asking me, what are the two numbers? It's not saying, where do these intersect? So you give me an ordered pair. It's saying, what two numbers have a sum of 25 and a difference of 3? The two numbers that have a sum of 25 and a difference of 3 are 14 and 11. Or 11 and 14. You're not going to be like, okay, Mrs. Long, you're right. So 1, 2, 3, 4, 5, right? You're not going to draw a graph to tell me this answer. It's not an ordered pair. It's two numbers. Let's add a few more words. There are 13 animals in a barn. Some are chickens and some are cows. There are 4 legs in all. How many of each animal are there? I'm actually going to change this from cows to horses.
Both have 4 legs.
I get it.
They're mutant
Calm
horses
down.
with 5 legs.
Cows and chickens.
Cows and chickens both start with the same letter. And when I define my variables, and I say C is for chickens,
Say CI and CA.
right, that's easy to remember.
CHI. No, CA.
And H for horses. Those are going to be my variables. I'm going to say C for chickens, and I'm going to say H for horses, because that's what I'm trying to figure out. Because it says there are 13 animals in a barn. Some are chickens and some are horses. There are 40 legs in all. How many of each animal are there? I'm trying to figure out how many chickens are there and how many horses are there. I've defined my variables. What are my two answers that they give me?
13 and 40.
So something equals 13 total animals, correct? ANIMALS. That was difficult. There's a total of 13 animals. What else do we know? What else is an answer? 40 legs. It gives me this information. It tells me two equations. Something's going to equal 13. Something's going to equal 40. Two equations in every system. I also have two variables. I have C for chickens and I have H for horses. Could you use X for chickens and Y for horses? Yes. But if you do that, you need to define it. You need to say, I'm using X equals chickens. Because when I get down here and do my math and you end up with X equals, you got to know what X means, right? Okay, so something's going to equal 13 and something's going to equal 40. Do you agree? How do you get 13?
C plus H.
The number of chickens plus the number of horses. Now, next part, we have to use a little bit of prior knowledge. Because it's not C plus H equals 40. Rosie, what is it?
Chicken legs and horse legs.
It's chicken legs and horse legs. So it's 2C
4H.
plus 4H. All right, so I set it up. C plus H equals 13, and 2C plus 4H equals 40. We can graph, substitute, or eliminate. If you love substitution, it's your favorite one, you could use substitution in this one. You have to get one of your variables by itself. If I get C by itself, that means I have to subtract H from both sides, meaning C equals 13 minus H. And could you now substitute? You could now, if substitution is your thing, it was your favorite out of the three, you could substitute easily on this equation. Most of you are going to choose not to substitute. Most of you are going to choose to eliminate. Can you eliminate right away? No. What should you do? Multiply the top by -2. You could multiply by 2 and then change it afterwards. Totally fine. -2 times C is -2C. -2 times H is -2H. And -2 times 13 is -26. Does the second equation change? 2C plus 4H equals 40. I agree. Let's combine like terms. Not us. -2C and +2C cancel out. They're inverses. What's -2H plus 4H? Equals, what's -26 plus 40? 14, is that what you said?
Yes.
Divide by 2, divide by 2, H equals, but what does that mean? It means that there are 7 horses. How do you figure that out?
13.
Because I know there's a total of 13, correct? Yeah? What does that mean, though? It means there are 7 horses and 6 chickens. Or could you say there are
6 chickens and 7 horses.
same thing, correct? But if it was an ordered pair, would the order matter?
Yes.
Yeah, ordered pairs matter,
Yes,
right?
it would.
But if they see before A,
No, there is no order in this one because it's not an ordered pair. All right, let's add more words.
No.
That's interesting.
Paul's school is selling tickets to the play. On the first day of ticket sales, the school sold 6 adult tickets and 8 student tickets for a total of $106. The school took in $128 on the second day by selling 8 adult tickets and 8 student tickets. What is the price of 1 adult ticket and 1 student ticket?
Too much.
2 things that you have to do. Maybe. 2 things you have to do. You have to find your two answers. What do you know? What are my two solutions to my equations? It's always going to give me my two solutions. The other thing you have to do is you have to define your variables. What are you being asked to find? There are the two things every time. Two things. Two variables, two answers. Two variables, two answers. Who has my two answers? Rosie, what are they?
6 and
106. And what is the 106 is the total of what? Day 1, right? Day 1 has a total of 106. I agree. What's my other answer? 128. And what's that the answer from? Day 2. Who has variables for me? Oishik, what are my variables? X, what do they mean? You have to define them. That's not what we're trying to figure out. What are we trying to figure out, Ian?
The prices of the adult and student tickets.
The prices of the adult and student tickets. So you could do A for adult and Y for student. I'm not going to put S for student because my S's look like 5s. Could you do X for adult? Could you do B for students?
Yeah.
Can you use any letter that you want? As long as you use two different letters, you're fine. You need to identify, define the variable. Because when you get to the very end and you're like, oh, great, X equals 4. You have to know what X means, correct?
Yeah.
All right, so let's set up the problem. Something equals $106 and something else equals $128. What equals $106? Day 1, correct? What do you know about day 1? 6 adult plus 8 student. Adult is my A, student is my Y. All right, day 2 was 128. What do you know about 128? Perfect, we gave our evidence. We used the information from our problem to create a mathematical system, an algebraic system. Ian.
Our adult ticket's $10.
Here we go. 6A plus 8Y equals 106. 8A plus 8Y equals 128. Do you want to graph it?
Yes.
Mm-hmm. I don't want to graph it. Do you want to substitute it?
No.
No. Do you want to eliminate it?
No.
Yes.
Do I need to multiply the top and the bottom? No. In fact, I can just change the bottom. Multiply the bottom by -1. 6A minus 8A is 6 minus 8 is -2A. My y's cancel out. 106 minus 128 is -22. Divide by -2. Divide by -2. A equals 11. What does that mean? Adult tickets. Oops, that's not how you spell tickets. Are $11. Then I take that 11, I put it into an equation. 6 times 11 plus
8y equals 106. 66 plus 8y equals 106. Minus 66 from both sides. 8y equals 40. Y equals, what does that mean? Student tickets are $5. Next problem, we have to fix two things because they don't work. Two typos. Jeff has a mixture of nickels and quarters. It is a total of, cross out 25 and put 24. And cross out a total of $5 and put $4. Jeff has a mixture of nickels and quarters. It is a total of 24 coins that totals $4. What do you know? Two answers. What are you being asked to find? To find the variables. Two answers, because there's two equations, and two variables. Oishik. Okay, so there's a total, I'm going to put equals 24 coins. Good. What else do you know? And it equals $4. Agreed. What do you know? We know that there are 24 coins and we know that there are $4. What are we being asked to find? So can I put N equals nickels? And Q equals quarters? Does that work? Now we're going to set up our problems. Something equals 24 and something equals $4. How do you get 24? Make sure you're writing this down, please, because you're writing it for homework. N plus Q equals 24, yes? What do you know about $4?
The 24 coins in total cost.
Yeah. But how do you get $4? Close.
0.05.
There you go. A nickel is not 5, correct? A nickel is 0.05. It's 5 cents, correct? And a quarter is not 25. A quarter is 0.25. So, how do we get $4? There you go. Now, I agree with you. That looks terrifying, don't you think? Those decimals. So, ladies and gentlemen, here's the trick. If I move the decimal twice here, what does it become? 5n. And since I moved my decimal 2 times to the first term, I have to move my decimal 2 times to the second term. And what does that become? Plus 25q equals, and I also have to move my decimal 2 times to the last term. 400. And n plus q equals 24. You want to graph it? Substitute? Eliminate? How do you eliminate? If you could substitute, it's fairly easy to substitute if you wanted to. How do you eliminate it? A negative 5. 5n plus 25q equals 400. Negative 5n minus 5q equals negative 120. You work. What happens here? Something cancel out? My n's? What's 25q minus 5q? Equals 400 minus 120 is 280. Divide by 20, divide by 20, q equals
14.
what does that mean?
There are 14.
14 quarters. Now I take my 14 quarters and I substitute them into one of the original problems. N plus 14 equals 24. How many nickels are there?
Like 800.
I'd check your math again.
That's a bunch of nickels.
10 nickels.
It's like 8 pounds.
All right, the next two problems we are going to do only the M and the E. We are only doing the M and the E. That's what you're doing for homework tonight. Tonight for homework, you have 8 systems, word problems, but all you're doing is the M and the E tonight for homework. All right, here we go. I'm going to read it. You fill out the M and the E.
Way too much.
The local amusement park is a fun field trip. This year, the sophomore class from North High School and the junior class from South High School planned field trips. The sophomores from North took 11 vans and 4 buses with 341 students. The juniors from South had 5 vans and 2 buses with 165 students. Each van and each bus carried the same number of students. Find the number of students in each van and each bus.